Hi everybody, this is Mr. Bradley, and this is a video solution for trajectories problems number 22 in your physics soft text. So I have the problem highlighted here on the screen, and it reads like this. A 0.45 kilogram ball is pushed off the table by a force of 7.4 newtons. The force is applied for 0.63 seconds while the ball is on the table. After the push ends, the ball rolls off the table, traveling exactly horizontally. The table is 75 centimeters high. The questions that are asked are letter A, what speed did the ball have when it left the table? Letter B, what horizontal distance does the ball travel while on the table? Letter C, how long will the ball be in the air? And letter D, what horizontal distance does the ball travel while in the air? So before we solve this problem, let's just unpack what we see here a little bit. It's pretty important to recognize that this is an interval problem. There's something that happens on the table, and then there's something that happens off the table. And the text is really specific about that. It tells you here that there's a ball here that's being pushed off of the table with a force of 7.4 newtons. This force happens for exactly 0.63 seconds. And then here's the key thing, while the ball is on the table. This is all information that really matters about the motion of the ball while it's on the table. Then it says after the push ends, the ball rolls off the table, traveling exactly horizontally. So also another very important thing. Finally, we find out that the table is 75 centimeters high. So what I have here is a force that starts a trajectory. And everything about the ball on the table has to do with the force problem. Once it leaves the table, it becomes a horizontally launched projectile that travels through the air with a velocity that starts only as Vx in the x direction. So this first question that's asked right here, what speed did the ball have when it left the table? This is really like the important thing that ties the trajectory problem to the force problem. This is that velocity that is the end of the first interval and becomes the beginning of the second interval. That's really going to be the final velocity at the end of the force is what that's going to be, but then it becomes the Vx to start the trajectory problem. So when you think about it, this speed here, I'm going to find that based on the information I have from the force problem. Also, this distance that I'm going to find here for letter B, that's going to be also part of the force problem because it says while on the table. That's the key thing. Now, once you get to these next couple questions, right, it says how long will the ball be in the air? Now you're basically talking about part of the trajectory problem because this is something that happens in the air. And in this question, when I say what horizontal distance does it travel, that's also while in the air. So let's go ahead and work through the solution to this problem. Okay, so we will go ahead and start this physics problem like we start every physics problem, which is with a good diagram of the situation. So we've got a ball that's basically sitting on a tabletop, and we know that the ball starts from rest and that it has a force that acts on it, pushing it towards the edge of the table. By the time that ball gets to the edge of the table, right here, it'll be moving with some velocity, and that velocity at the end of the force we will call the velocity in the x direction for the trajectory, and then it will take off in this trajectory, and it will come down to the ground and end up crashing and hitting the ground down here. So let's see here. The information that is given to me here is that the mass of the ball is 0.045 kilograms. I also know that the net force that acts on the ball is 7.4 newtons. So in this diagram, I probably would label this force vector as 7.4 newtons. With mass and net force, I can find acceleration. Net force divided by mass equals acceleration. And so when I take 7.4 newtons and I divide by 0.45 kilograms, I get 16.44 repeating meters per second per second. So if the ball has that acceleration, while it's being pushed on the table, I can calculate what the final speed will be. The problem tells me that that force is applied for a time of 0.63 seconds. Okay. Now what's really important here to recognize is that this time is the time that the force lasts for. This is all part of the force problem. So I know that the final velocity that the ball will have will be equal to the initial velocity plus AT. Since it starts from rest, the initial velocity is equal to 0. So really, it's just going to be 16.44 meters per second times 0.63 seconds. When I calculate that, I get 10.36 meters per second. So that's the velocity that the ball will have when it's launched off the edge of the table. So before I go to, well, and actually, I'm sorry, that's just the answer to letter A. Letter A says, what is the velocity as it leaves the table? That velocity will be 10.36 meters per second. This answer only has 2 sig figs in it based on the numbers that I used. So this is going to be 10 meters per second. That's my answer for that first question. Now before I go further, let me just make sure I indicate everything I did right here is part of a force problem. Okay? The part of the force problem I want to know now is what distance does it move on the table? Well, I can find distance when I know acceleration and speeds and times. There's lots and lots of different equations I can use here. I would say the best one to use, I think, is going to be d equals 1/2 at squared. Remember, that's the kinematics equation that you'll use if the initial velocity is equal to 0 and you have acceleration and time. So when I do that, I'm going to take 1/2 times 16.44 meters per second times 0.63 seconds squared. When I punch that in my calculator, I get 3.2633 meters, and with my sig figs, that is going to be 3.3 meters. So that actually is also still part of the force problem that I did right up here. Now what I'm going to do is solve things about the trajectory problem. Now what I care about is what happens after it leaves the table. And so the first question there says, how long will the ball be in the air? I'm basically looking for the time in the air. Well, the time in the air, when you're talking about a trajectory problem of this sort especially, depends completely on the height from which the object was dropped, right? That's the distance in the y direction. Well, in this problem, it tells you that the table is 75 centimeters high, so dy is equal to 75 centimeters. It's a good idea to convert that to meters just right away, so that's 0.75 meters, and because it's going to fall a distance of 75 centimeters, then I need to make that a negative number. Now it's just a matter of me finding what is the right equation in this scenario, and the kinematics equation that'll apply is the square root of 2 dy over ag. That's the kinematics equation that you use when the initial velocity is 0 in the y direction and when you know the height of the table. So I'm going to say 2 times negative 0.75 meters divided by negative 9.81 meter per second per second. When I do that math, I get 0.39 seconds. That seems like a pretty reasonable answer for me. When I consider the ball in the cup lab that was done in class, I know that those tables were right around 75 centimeters, and I think the time in the air was something like 0.38 seconds, so this time seems pretty reasonable. So now last thing I'm going to do, letter D, the question asks, what horizontal distance does the ball travel while in the air? So when you're talking about a trajectory problem like this, if I'm asking for horizontal distance, I'm asking for dx. I'm asking for the distance in the x direction. The distance in the x direction depends solely on how fast the object's moving in the x direction and how long it is in the air. So I already have both of these answers. Remember, my Vx is actually what the final velocity of the ball was when it left the table, which was 10.36 meters per second. So I'm going to take 10.36 meters per second, and I'm going to multiply that by the time that the ball was in the air, which is 0.39103 seconds. When I multiply those two numbers on my calculator, I get 4.0510 meters, and with the two sig figs that I have in this problem, I get 4.1 meters. So this ball is going to go pretty far out from the edge of the table, 4.1 meters, but honestly, that kind of makes sense when you consider the fact that it was going 10 meters per second when it got kicked off the edge. That's a pretty fast horizontal speed. Hopefully this solution helps you work out this problem. It's important that you be able to relate force and trajectory problems together. Thanks for tuning in.